Hello and welcome to my presentation where I'm going to be talking about the use of intrinsic feedback in improving running mechanics. Okay, so I have two objectives. Firstly, I'm going to be talking about the concept of intrinsic feedback over augmented feedback when coaching running, and secondly, I'm going to discuss how we can use intrinsic feedback to improve our athletes' running mechanics. Okay, so firstly, why is having a good running mechanics important? Okay, so without going into too much detail with the science behind it, essentially good running mechanics can reduce the risk of injury and improve an athlete's running performance. Okay, so when considering running performance, running economy is regarded a good physiological predictor to running performance. It also shows a relationship with running mechanics. Okay, one study showed a 54% variation in running economy associated to running mechanics. So this is something as coaches we can utilize to improve our athletes' running performance. However, if we're going to look to improve our athletes' running mechanics, then we need to come up with an optimal and technical model and key markers that represent this model. However, running is a natural and continuous skill which can offer a variety of movements, which is like Bernstein's phase, repetition without repetition. This essentially means different movements can still have the same result. Okay, so what I'm going to do is I'm going to quickly go through some of the key markers within the literature which can affect running performance. It is, however, worth considering that these key markers may vary based on goals, whether that's speed, running economy, or injury prevention. Okay, so reduced contact time is associated to a better utilization of elastic energy, which can be described as free energy. Increased leg cadence and stride length is associated to an increase in speed. However, a reduced stride length is also associated to improved running economy. Vertical oscillation, reduced vertical oscillation, which applies to less energy being wasted oscillating up and down. Ground contact underneath center of mass implies to less braking forces. A slightly dorsiflexed ankle can be considered as the foot being cocked and allows greater utilization on the stretch reflex. And lastly, mid to forefoot strike, which tends to be more prevalent as an increase in speed, however can also show an improved running economy. Okay, so now looking at feedback, this can be considered as gaining information to aid our decision making process. So here we have the model from the textbook from Rose and Christina, and as you can see there are two branches. So we have intrinsic feedback and augmented feedback. So intrinsic feedback or sensory feedback is feedback our body provides us. So this can be visual, so sight, auditor, so stuff we hear, proprioceptive, so how the movement feels, cutaneous, how the movement may feel, but more kind of textual or touch. Then we have augmented feedback, which is more kind of external feedback, which could be knowledge of performance, which is essentially feedback on the process, and knowledge of results, which is essentially feedback on the outcome. Okay, so in reality, we'll probably use both methods of feedback. Augmented feedback is probably the feedback we would use within our coaching session. However, as coaches, we want to influence our athletes to utilize intrinsic feedback as much as we can. Okay, this is because it allows the athlete to self-manage their performance outside of our sessions and potentially provide better and faster results. It is also something that elite and more experienced runners probably utilize better, and this is probably from a greater knowledge and understanding of the movement. So this is something I'm going to look at within this presentation, is how we can utilize this intrinsic feedback to improve our athletes' technique. Okay, so our bodies are consistently providing us with feedback through our senses. For example, if we're dehydrated, we become thirsty, we drink. When we feel pain, we try and avoid that same stimulus. However, the feedback we received is very much kind of related to the environment and that stimulus. So basically, if it's hot or cold, this changes the stimulus and therefore changes our response. Okay, and this very much kind of underpins the ecological psychology theory first presented by Gibson in 1986, who raised the importance to consider the interaction of the performer and the environment when learning. Essentially, the performer becomes more attuned to the constraints of the environment and acts upon these constraints. Also, athletes are probably more receptive to changes in intrinsic feedback. Okay, this may seem a little anecdotal. However, when you consider movement changes due to fatigue or injury, it actually in some makes some logical sense, and is also likely to explain why we adopt certain compensatory movement strategies. Okay, so as coaches, we have the ability to control the environment and the stimulus that's presented to the athlete. And this very much kind of follows the constraints-led approach when Newell in 1986 proposed that if we can manipulate constraints, then we can manipulate the control and coordination of movements. Again, he came up with 3 categories for these constraints. So we have task constraints, which can be manipulated by the coach by changing the goal of the task, orgasmic constraints, which can be manipulated again by the coach by maybe putting the athlete under a strength program and improving the athlete's strength, and environmental constraints, which would be changing the environment and how the athlete would be interacting with the environment. Okay, so how can we manipulate some of these constraints to alter the athlete's intrinsic feedback and then essentially change their running mechanics? Okay, so I'm going to look at the use of barefoot running, which would be manipulating the environmental constraints as we'll be changing how the foot is interacting with the ground. Okay, so barefoot running increased in popularity based off the best-selling book Born to Run by Christopher McDougall, and also the research of Dan Lieberman, which essentially said that modern trainers have been developed more for comfort rather than function, which has influenced the way we run. This theory implies that barefoot running increases the sensory feedback from the foot, and then in turn changes the way in which we run. Okay, so the debate regarding the suitability of barefoot running is still relatively inconclusive. However, there is a wealth of knowledge and research that indicates that this still influences changes to running mechanics. Again, this is what we're going to look at. So when considering the foot, when the foot comes into contact with the ground and the feedback the foot provides us, we can consider that landing on the heel is probably more painful than landing on the toes, and this makes logical sense. So if we were to jump up now and land on our heel, it's going to hurt more for most people than if we land on the front of our toes or on our toes. Okay, so this potentially is why a mid to forefoot strike tends to be very common and characteristic within barefoot runners. It is believed that this mid to forefoot strike means that the foot lands closer to the center of mass, and then in turn reduces the braking forces, but then also gives it a better chance of utilizing stretch reflex and therefore improving running economy. However, when considering running economy, as mentioned before, a slightly dorsiflexed angle has also been associated to improved running economy. Okay, however, a reduced ankle dorsiflexion also tends to be characteristic within barefoot running. Therefore, this indicates that barefoot running can negatively influence key markers to running economy. Okay, so this slightly plantar flex foot could be considered as a coping strategy to soften the landing of when running barefoot. This reaction again is most likely due to intrinsic feedback and the sensory receptors within our foot. Again, this is another interesting research from Moody et al., which compared varying differences in cushioning in barefoot running in novel minimalist runners. Okay, so the results showed a linear progression to an increase in both ground contact time and vertical oscillation to the level of cushioning. So as the level of cushioning increased, so did the ground contact time and vertical oscillation, which are markers of running economy. It also showed a significant difference between barefoot running and the 12mm drop trainers. These changes are also likely due to be an increase in sensory feedback. It is important, however, to consider that the participants were minimalist runners, and so that the result and the biomechanics could vary if the participants were shod runners. It's also worth considering that the only significant difference was between barefoot running and the 12mm drop and none of the other conditions. Okay, so when looking at the risk of injury, this is probably the biggest argument against the suitability of barefoot running. However, the literature has shown mixed conclusions. It is definitely an important consideration when looking at good running mechanics. However, it's a very complex issue, and is likely to be many different variables, such as the individual, the speed, distance, and surfaces. However, research has shown that barefoot running has been shown to reduce risk of injury, predominantly in the knee. However, conflicting research has also shown that barefoot running can increase risk of injury to the Achilles and foot. Therefore, it seems that the overall risk of injury isn't prevented by barefoot running, but it's more the change in localization of the injury. Okay, so this can be argued to be because that the foot is not conditioned to run barefoot as a result of a lifetime of wearing cushioned shoes. However, an increase in sensory feedback to the foot during barefoot running is probably more likely to detect painful movement patterns more quickly. So maybe it's more about interpreting this sensory feedback by the athlete, but also potentially through better control of training volumes, and maybe having a robust screening model that can predict the suitability of an individual for barefoot running may also look to kind of reduce the rate of injuries within barefoot runners. Okay, so in conclusion, changing environmental constraints is likely to change the intrinsic feedback the athlete receives. So these changes in intrinsic feedback is likely to alter the athlete's running mechanics. Therefore, we can use barefoot running as a tool to alter certain key markers of good running mechanics. However, it is important to be objective with this, and to look at what we're trying to achieve to ensure that this is still in line with the athlete's goals, but then also it's in a progressive way. It would also be interesting to have a look at other methods to explore how we can manipulate other constraints and see if this can influence the intrinsic feedback, potentially through using running drills or non-motorized curve treadmill. And lastly, I think feedback should be used to educate, influence, and develop the athlete's knowledge on their understanding and perception of intrinsic feedback. So essentially teach the athlete to be more in tune with their bodies.